All right, for the advanced problems, question 5.9 in forces, it is asking us what is the acceleration of m1, which is the crate in this diagram. So to find it, we first have to get all the equations for the forces. But first, we need to realize the acceleration in this is going up the x-axis or up the incline. For this question, we're having the incline be the x-axis. But the mass is going down at first in this image. That's why the force of friction is going up. You could have the velocity going down and the acceleration going a different direction. That is fine. So we need to see the relationship of the accelerations of m1 and m2, and that is depicted here in this diagram. We know a1 is different from a2 because there is an angle that from this the connected masses. This string is making an angle due to this pulley being elevated instead of like normal like previous questions we've done. So the m1 acceleration is a2 cosine phi. This angle here is phi, this is theta. These angles are different. Note for the rest of these equations, you need to be careful about the angle. So now that we got this relationship, we need to solve for the forces in each of the masses. Now for m2, the net force in the y direction, I'm doing this one first because it's easier and I guess clearer to see. So we have tension going up, the weight going down, and we're solving for tension, which is this expression over here. Now for the net force in the x direction of m1, be careful, remember, be careful with the angles. So we have t cosine phi, I'm not sure if you could see here, but phi, this says t to subscript x, not sure if you could see that, t cosine phi plus force of friction going same direction minus m1g sine theta. The component of the weight from m1 would be sine theta going in the negative x direction. Now we got this expression right here. Now for the net force in the y direction of m1, we have, I used color just so you could see it kind of clearer, the normal force going up and the tension sine phi also going up. So you're adding them minus m1g cosine theta. This equals 0 because, well, m1 isn't flying up or like going into the incline, it's 0. And now we get the expression for the normal force. So these are the 4 expressions you're going to need for this next part. Now, in this next part, we have these 4 expressions again, right? Now we're just going to be plugging in and solving for, what we're going to be solving for is A2. Now you're going to see why in a second. So after plugging in normal force into here, and then tension into the tension here, and then the tension here you get due to the plugging in normal force equation, you get m1 a1 and this expression here. Now the accelerations are a2 and a2 over here. So we're going to plug in this first equation we got to a1. So we get like all the accelerations into the a2 value. Now after simplifying the heck out of this equation, we get this weird expression over here. And then due to this expression, you have a2. Now, again, using this equation, we can say a1 is equal to a2, which is this mess, times cosine phi. And that is how you get the acceleration of the crate. Now, I did not show, the question's done. If you want, you could stop watching the video. But you could also see how I got this expression. If you were able to get it, you can stop the video now or keep watching. Okay, so this mess over here, I will try to explain it. Now, if you already have this, you don't have to keep watching. I'm just going to explain to those that had trouble getting this expression. So we left off with m1 a2 cosine phi equals m2g minus m2 a2 and the rest, right? What you have to do to get a2 by itself, you have to start distributing every like constant you see here. So after distributing, right, I distributed a cosine phi here, and I slowly distributed the mu into this part of the expression because it's a mess. You could try seeing this, but just do the work, and then you could see after distributing. And then you isolate the A2. So after distributing, isolate the A2 acceleration, and then you get A2 times m1 cosine phi plus m2 cosine phi minus mu m2 sine phi. Remember, be careful with the angles. And that equals, I put x plus y, I put that just to make it like all fit. X would equal this, y would equal this value, I have arrows, and then negative z would equal minus m1g sine theta. So after you get all this, you can start like plugging things back in, and then you finally get this expression. You divide, and then you get m2g cosine phi plus mu m1g cosine theta minus mu m2g sine phi minus m1g sine theta all over m1 cosine phi plus m2 cosine phi minus mu m2 sine phi. And that is it. This mess is done.